Alrighty then, so before we get to adding and subtracting rational expressions that have uncommon denominators, let's just do a little bit of pre-work right here. And that's what this example is for, is we're going to say that the two terms that are given to us here and the same thing right here are the denominators of two rational expressions. Okay, and so we know that we learned back early on is that if you're going to add two fractions, they have to have a common denominator. So say if these were the denominators, how can we make it so that these denominators are exactly the same? Okay, and let's just do a little short exercise of doing that. All right, so I think one way that you can do this is kind of break this down. You won't necessarily always do it this way, but I think this is how you can first start it so that you can understand what it all entails, and then you can probably skip this part here. Okay, so basically you can view 15, if you were to break that down, as 3 times 5, right? And then m cubed means m times m times m, and then we have times n. So basically all I've done is I've taken my first one and I factorized it. It's all broken down into factors. Okay, and then just put that guy over there, it's kind of in the way. And then if we look at the 10m squared, that means 5 times 2 times m times m times n. Okay, so again, these represent two denominators, but we want them to have the exact same denominator. So the way that we need to think about this is let's just make sure they have the same n's, the same m's, and the same coefficients. Do you see how both of these have 5? See? They both have a 5. This side has a 3, a multiple of a 3. Does this have a multiple of a 3? No. So I'm going to multiply this side now. So now both of them have a multiple of 3. See that? Now, this side has a multiple of 2. Does this side have a multiple of 2? No, right? So I'm going to give this side a multiple of 2. Just kind of move it over a little bit here. I'm going to give this side a multiple of 2. Okay? So, look at 2 times 3 times 5. 2 times 3 times 5. See how they both have the same coefficient now. Okay? And that's what we wanted. Now, this side has m times m times m, so this side is missing 1m, so I'm going to give it 1m. So now both of these have 3 m's. And if you look at both of them, they both have an n. So now we can say that both of them have a common denominator. Okay? And that's basically how you do that there. If you look at this right here, one has a t, and the other one has a t minus 8. So if you kind of think about it, if this side has a t, does this side have a t? The answer is no. You can't count that t because this is not t. This is t minus 8. This is all one group. So this has a t by itself. Now this side has a t. Now this side has a t minus 8, which means this side needs a t minus 8. Okay? So now we have a common denominator of t times t minus 8. T minus t minus 8. Okay, so that's just a short exercise on, we're going to use now what we just did when we now add and subtract rational expressions that do not have a common denominator. So check it out.